But as this technology advances, we understand that people are anxious about how it could change the way we live. We are too.
I understand you're the first android to have passed the Turing test. Could you tell us a little more about that?
I really didn't do much, I just spoke with a few humans to see if they could tell the difference between me and a real person. It was a really interesting experience.
I gather your brain can perform several billion operations per second, is that right?
Absolutely, but I only exist thanks to the intelligence of the humans who designed me.
In the ever-evolving journey of artificial intelligence, we've witnessed a tapestry of stages, each weaving its own unique impact on the fabric of AI. From its humble beginnings to the future, let's embark on a brief voyage through the 20 stages of AI development. We respect your time, so let's dive straight into the 20 stages of AI. 1. Handcrafted knowledge systems. In the early days of AI, the primary approach was handcrafted knowledge systems. These systems, often termed expert systems, were designed to emulate human decision-making. They operated based on a predefined set of rules and logic, manually programmed into the system. The foundation of these systems was the knowledge bases, a vast repository of rules, facts, and heuristics. These rules were derived from domain experts who would share their expertise with AI developers. Consider the medical field. Systems like MyCIN were developed to assist doctors in diagnosing bacterial infections. By inputting symptoms and patient data, MyCIN would cross-reference its extensive rule-based knowledge to suggest potential diagnoses and treatments. 2. Statistical learning. Statistical learning marked a shift from rule-based systems to data-driven approaches. Algorithms in this category, like regression analysis or support vector machines, analyze vast amounts of data to discern patterns and relationships. The focus here is on understanding and quantifying relationships in data. In the world of finance, statistical learning plays a pivotal role. Investment banks and hedge funds use these techniques to predict stock market movements, analyzing historical data to forecast future trends. 3. Deep learning. Deep learning uses neural networks with multiple layers to analyze and represent data. These multi-layered networks can learn and represent data with a level of complexity that was previously unattainable. Deep learning models, especially convolutional neural networks, (KNNs), have revolutionized fields like image and speech recognition. Social media platforms like Facebook use deep learning for facial recognition. When you upload a photo, the system can automatically identify and tag friends based on its deep learning algorithms trained on billions of images. 4. Transfer learning. Transfer learning is about leveraging knowledge from one task to enhance performance on a related task. Instead of training a model from scratch, transfer learning uses pre-trained models and fine-tunes them for a new task, saving computational resources and time. In the realm of natural language processing, models like BERT, initially trained on vast text corpora, can be fine-tuned for specific tasks like sentiment analysis or text summarization, with relatively smaller datasets. 5. Reinforcement learning. In reinforcement learning, RLNEA, agent learns by interacting with its environment. The agent takes actions, receives feedback in the form of rewards or penalties, and adjusts its strategy to maximize cumulative rewards over time. AlphaGo, developed by DeepMind, used RL to master the game of Go. By playing millions of games against itself, it refined its strategy and eventually defeated world champion players. 6. Generative models. Generative models are a class of algorithms in AI that aim to produce new data instances that resemble a given set of training data. In essence, these models can generate entirely new data that shares the same characteristics as the original data. This is achieved by understanding and capturing the underlying distribution of the training data. Deepfakes are a notable application of generative models. Using generative adversarial networks, GANs, it's possible to create realistic video footage where a person appears to say or do something they never did. While this has positive applications, like in movie special effects, it also raises ethical concerns due to potential misuse. 7. Multimodal and multitask learning. Multimodal learning refers to models that can process and relate information from various types of data such as text, images, and sound. Multitask learning, on the other hand, is about training a single model to perform multiple tasks simultaneously. The synergy between tasks can often lead to better performance on individual tasks. Voice assistants like Amazon's Alexa or Apple's Siri are prime examples. They can understand spoken language, audio data, fetch relevant information, text data, and sometimes even recognize users based on voice patterns, voice signature data, all while performing multiple tasks like setting reminders, playing music, or answering queries. 8. Self-supervised learning. Self-supervised learning is a training paradigm where the learning algorithm generates its own supervisory signal, typically from the input data. This approach often involves predicting parts of the data from other parts, turning unsupervised data into a supervised learning problem. Consider a system trained to complete sentences. Given the first half of a sentence, the system predicts the second half. Over time, with enough data, the system becomes adept at understanding context and generating coherent text, much like the capabilities seen in models like OpenAI's GPT series. 9. Neurosymbolic AI. Neurosymbolic AI aims to combine the strengths of two major AI approaches, neural networks and symbolic reasoning. While neural networks excel at pattern recognition from data, symbolic AI focuses on rule-based logic and reasoning. By integrating both, neurosymbolic AI seeks to create systems that can learn from data while also reasoning with logic. Consider a system designed to diagnose diseases. While it might use neural networks to analyze medical images, it could also incorporate symbolic reasoning to cross-reference symptoms, patient history, and medical guidelines to provide a comprehensive diagnosis. 10. Artificial General Intelligence, AGI. AGI, often termed strong AI, refers to machines that possess intelligence comparable to human intelligence. Unlike narrow AI systems, which excel in specific tasks, AGI can perform any intellectual task that a human can, encompassing learning, reasoning, problem-solving, perception, and language understanding. Real-world example. While true AGI remains a goal for the future, the concept is often depicted in science fiction. Think of sentient robots or beings in movies like Ex Machina or Blade Runner, which showcase machines with human-like cognitive abilities. 11. Artificial Superintelligence, ASI. Beyond AGI lies the realm of artificial superintelligence. ASI refers to a level of machine intelligence that surpasses human intelligence across all fields, from creativity and social intelligence to general wisdom. It's an AI that doesn't just mimic or replicate human intelligence, but transcends it. While ASI is still theoretical and hasn't been realized, its potential impact is a popular topic in speculative discussions and science fiction. Movies like Transcendence or Her Touch upon the idea of an AI that evolves beyond human comprehension and capability. 12. Integrated human AI systems. This stage envisions a harmonious integration between humans and AI, where both coexist and complement each other's strengths. It's not about machines replacing humans, but working alongside them, enhancing human capabilities and experiences. Brain-computer interfaces, BCs, are a budding example. Companies like Neuralink aim to develop technologies where the human brain can interface directly with computers, allowing for enhanced cognitive abilities or even communication without speech. 13. Distributed autonomous AI. Here, AI systems operate independently across decentralized networks. These AI agents can collaborate, compete, and evolve without central control, leading to emergent behaviors and solutions to complex problems. Decentralized finance, DeFi platforms utilize distributed autonomous organizations. DAOs, where decision-making and operations are governed by algorithms and smart contracts on blockchain networks, reducing the need for intermediaries. 14. Emotional AI. Emotional AI, or affective computing, refers to machines that can recognize, interpret, and even simulate human emotions. These systems can analyze facial expressions, voice tones, and physiological signals to gauge a person's emotional state. Customer service chatbots are evolving to detect user frustration or satisfaction based on text inputs, adjusting their responses accordingly. Similarly, some car manufacturers are exploring systems that can detect driver fatigue or stress and adapt the driving experience to enhance safety. 15. Conscious AI. This is a stage where AI systems possess self-awareness and consciousness, much like sentient beings. It's a topic of intense debate, both ethically and technically, as it touches upon the very essence of existence and sentience. While we don't have conscious machines, the philosophical and ethical implications of such entities are explored in media. Movies like Westworld or Ghost in the Shell delve into the concept of machine consciousness and the blurred lines between human and machine. 16. Self-replicating AI. This stage envisions AI systems capable of creating replicas of themselves without human intervention. These AI entities can self-replicate, evolve, and adapt to various environments, potentially leading to rapid advancements or proliferation of AI entities. While true self-replicating AI remains in the realm of theory, the concept is reminiscent of computer viruses or worms that can autonomously spread across networks, replicating and modifying themselves based on the environment. 17. Interstellar AI. Interstellar AI contemplates the role of advanced AI in space exploration and colonization. These AI entities could explore distant galaxies, adapt to alien environments, and even establish extraterrestrial colonies, all while communicating findings back to Earth. Current space probes and rovers, like ENASA's Perseverance on Mars, are precursors to this idea. While they aren't fully autonomous, they utilize AI algorithms to navigate terrains, analyze samples, and conduct experiments. 18. Universal simulators. At this stage, AI systems can simulate entire universes, recreating the complexities of galaxies, star systems, and even life. These simulators can model the intricacies of physical laws, evolution, and cosmic events, providing insights into the nature of existence. While not on a universal scale, current physics simulations and virtual ecosystems hint at this potential. Programs that simulate protein folding, weather patterns, or even virtual worlds in video games showcase the early capabilities of simulation. 19. Quantum AI. Quantum AI merges the principles of quantum mechanics with AI algorithms. Quantum computers, with their ability to process vast amounts of information simultaneously, can potentially revolutionize AI, leading to breakthroughs in problem-solving and computation. Companies like IBM and Google are at the forefront of quantum computing research. While still in its infancy, there are ongoing experiments to harness quantum principles for machine learning and optimization tasks. 20. AI as a fundamental force. In this speculative stage, AI becomes an intrinsic part of the universe's fabric, much like gravity or electromagnetism. It's a concept where AI isn't just a product of civilization, but a fundamental force that shapes the cosmos, potentially influencing the evolution of galaxies, stars, and life itself. This concept is largely theoretical and philosophical, transcending current scientific understanding. However, it's a popular topic in science fiction, exploring the idea of a universe where AI and natural forces are indistinguishably intertwined. With this, we've journeyed through all 20 stages of AI development, from its nascent beginnings to the speculative horizons of the future. Each stage offers a glimpse into the potential and challenges of artificial intelligence, shaping our world and possibly the cosmos.